Hello my friends, welcome again to my video channel. Today we'll start a new project, SOMMERKAMP FT221 version Romeo. It's a VHF transceiver from the late 70s. I think it was produced up to the 80s, I'm not quite sure. It's an analog transceiver for VHF. It's one of the first transceivers with PLL, not with a standard premixer. The VFO, the internal VFO, controls the output and input frequency via a PLL loop. The other transceivers on the market were from Kenwood, the TS700 in different versions, G and S. ICOM had a transceiver IC201, a little bit later IC211, which was then also a PLL transceiver, and in those days also a German company, Braun, was active with the SE400 line. You will find all these transceivers in my videos on my channel, earlier videos, where all have been repaired or restored, partially really restored. But up to now I had no FT221. That's the reason why I've bought some, I think 2 years ago, and then it was sitting under my workbench. So let's have a look at it. This transceiver is in rather good optical shape. We have here the band setting from 144 up to 147.5. So this transceiver runs up to 148 megahertz. It is not a European version, maybe a US version. We have here the VFO. It's an analog VFO, as we have seen. It's still moving smooth, silky, so it's very good. Only something rubs, but that's not a problem. We have the mode switch, LSB, USB, CW, AM. It was a time when the transceivers had AM mode and FM. Here we have a clarifier which can be switched on for RX, TX, or only RX marker. Meter can be switched from discriminator to S meter unit. And here the repeater shift, normal, reverse. It can be switched on and off. Microphone gain, audio frequency gain, square function for FM and RF gain. Here some channels, VFO, and also some crystals can be selected to have channels. These were the days when the VFOs were not so frequency stable and precise, so it was wanted by some customers to have crystals for fixed frequencies for repeater channels. And so in general it looks rather good. On the side also some scratches, okay. That's the rear side with the connections. With the antenna grounding, something for the SIC ALC make and break, for the relay output for the control of a PA. Tone input, I don't know exactly what this is, maybe for selective call or something like this. And here we have the power connection. The power transformer is built in for 220 volt operation. Here we have the other side, microphone holder. Well, in general it looks rather good optically from the outside, so let's have a look into the guts. Yes. Here we have a look in the inside and the modules. These modules are all plugged. That's a very good construction, contrary to the Kenwood TS700, where we have a lot of boards. They are all wired, but cannot be taken out. These boards can be taken out. But I see what I don't like, modifications, and I didn't know it when I bought it. Here someone made a wire. What for, I don't know. Here is a wire. From here to here. And this wire goes from there to there. Is it connected to the switches? I don't know. Here's also a set of cables. Oops, what is this? This wire is pinched off. This wire is also pinched off. Here's a wire pinched off, the original wire hanging in the air. This one is also Well, that is the meter. The meter can be switched from a function to another function. This is a switch for it. Oh my god, oh my god. Who did this? That is what I like. In the worst case, this could be the death penalty for this project. I'm not sure. Because it's always difficult to follow up the modifications. Such a long wire here. It's at least a meter for switching an instrument. This is for the RF gain. This is one of the famous modifications for the RF function. There's a hero who modified the RF gain setting. Oh my god, oh my god. Well, you see, there's something to be done. Luckily all boards are present. And no one slaughtered it. That's the power transformer. That's nice. Big one. Final power amp. I think this is original one. Okay. But again, luckily these boards can be taken out. There's one crystal selected or set. Channel 1 from 12. Is it 12 channels? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 11. Number 1 is obviously equipped. There's another wire. Oh no. Oh no, no, no. Yes. I know what to do. There is something to be done. Well, you see, I'm speechless. That's always a problem to work with such transceivers. I will remove now the bottom cover and have a look onto the bottom side. I hope there are no further surprises. Well, that's the bottom side. This plug here is from the loudspeaker. I removed it. It looks original. I can't see any signs of tampering or so. These cable ties here are the original ones in the original position. These are also the old ones. I think so. On the switches we have also no problems. It looks good. Here also original. These electrolytics, well, I think they have to go, but that's not the problem. Yes, I think it's okay from the optical appearance, and I think there is a good basis for restoration. And yes, this is a restoration. That means bringing it back to the original state, not only repair some bad components, we have to restore it. That's the tapping for the power transformer. I have to look in which position it is. Maybe it's in the 220 volt position. We have 235 volt now, so I should use the 117. Well, seems obviously okay. But the only thing what we have to do in the first step is to check what these cables are good for and why the guy didn't shorten these wires. I don't understand. But I don't have to understand everything. Well, I found here 3 additional pinched off and hidden wires, and I think they have been connected to the RF gain, because the RF gain is rewired to the PLL unit in parallel to this trim pot. Why did someone rewire this pot parallel to the trim pot on the PLL unit? What for? we will see what this trim pot does. Maybe we can understand it, but I think, or I'm quite sure, that one of these wires, okay, there is a fourth wire, but this pot only has 3 pins. 4 wires for 3 pins. It's a challenge. First thing, we have to look into the schematic and to identify this modification, and this one here. What happened with the meter? The first mod we will remove is the mod of the S meter function. Here we have with this switch the option to feed out the information for the S meter, which is this gray wire which was connected to the meter here, which is fed now to the center of the switch, and it can be selected whether it is fed to the meter itself, to the yellow one, so we have the connection, or it was an option to connect it to an external. I assume it was an external wire with the switch. I don't know what it is for, but I will remove it. The next mod is this wiring here, which is connected to the RF gain pot. We have here 5. I found a 5th wire, which is obviously cut and was connected here, but not to this pot. The original RF gain pot has 2 pots. It's a stereo pot. One is connected with 3 wires and the other one is connected with 2 wires. They are used for the RF gain. We have it here. One is a true pot, as we see, which goes to the SSB IF unit, and the other one is only a pot to ground, which is connected to the RX-RF unit. So we have 2 pots, stereo pots. The problem is they have 500 ohms. Stereo pots 500 ohms are not so available on the market. 1 kilo ohm, 2 kilo ohm, 5 kilo ohm, no problem, but 500 ohms, a stereo pot is difficult to find. So I will think about the option to replace these 500 ohm pots by a 1 kilo ohm pot, and maybe I will add some resistor in parallel and think about how the circuit is affected. I don't think that it is a big problem, because the input impedance in the SSB IF unit is rather high, and the resistor with 1K is also okay. We have only to consider that there are trim pots on this board which are designed for the 500 ohm, so I think I will use a 1K pot with 500 ohms in parallel. Same principle here, 500 ohms and 1 kilo ohm and another kilo ohm in parallel. We will check, or I think about the characteristic, whether it is deadly or not. I'm sure it is not deadly. Maybe we can have some small advantage. So first I will remove the wiring here and check what it is connected on the PLL unit, what the sense is for it. I really do not understand it. I took this unit out, the PLL unit. Contacts are okay, obviously on the rear side also. And here we have the modification. It is in parallel with this trim pot. First I will unsolder it, and then we will check which pot is it in the circuit and what reason it might have to connect this pot in parallel to this trim pot. This pot with the 2 wires was in parallel with this trim pot VR301, and it is part of the PLL circuit. One moment. The FET receives the PLL voltage from this mixer, and with this pot the bias is set for this FET, and the output signal, this is a power supply rail, the output goes via this resistor So I wire this resistor 47K to the vary cap of the oscillator. And this pot here determines the stability of the PLL. And it's stated in the manual it has to be set for best stability and for a stable PLL and not for unlocking and so on. Why there is a pot in parallel fed to the front of the transceiver, I have no idea. This has to be set and never be touched. Whatever this guy did or thought, I think it was okay, no comment. It is removed now. Of course, we have to realign this pot according to the manual. Here is a fault and it has to be corrected. There are some signs of soldering on the rear side of this board. It's especially in the range of the oscillator where the trim cap is and the coil. Maybe there was a stability problem. And the guy tried to solve this problem with his pot. But when there's a problem, we have to solve it. And not to overcome it with such a strange modification. These solder connections look still rather good. I don't see any halos or so. Okay, we have some old electrolytic caps. Maybe they have to go. But at the moment I do not repair this one because up to now I didn't fire up the unit, and I will try to leave it as it is and then chase for faults when we energize or power up the whole unit. But at the moment I do nothing here. The next modification is connected to the pilot lamp of the VFO drive. There's a wire connected, and this wire is connected to the RX RF unit. This is strange. Why is there a connection? Well, I have an idea, but first I will check it. Where it is connected to the RX RF unit, and then we can discuss about it. The main modification of this board is the R409 is removed. This resistor does not exist, also not on the bottom side of the board, but instead of this resistor, this wire here is connected. We can see it here. So let's have a look into the schematic. R9 is this resistor, 1.5K, and this resistor is deleted, it's not existing. But this point is connected to the pilot lamp. And then it's important to know what the pilot lamp does. The pilot lamp is controlled by the PLL. If the PLL is okay, then the pilot lamp is connected to ground on one side and is lit. The pilot lamp is the lamp for the VFO illumination. And when the PLL is unlocked, or when there's a problem with the PLL, this pin goes high. The pilot lamp, which is connected on the other side to plus 12 volt, is dark, and then we have the plus 12 volt here. And this is the input transistor, and then source goes positive. So this is intended to block this transistor. Source gets positive when this resistor is not present. This modification, by the way, we have the RF gain connected here to this pin, to the 100 ohm. And when the RF gain is 500 ohms, we have a similar effect that source also goes positive and blocks the transistor. But why was this modification made? This means that in case of a PLL unlock, the input transistor is muted. I assume parallel to the blinking LED. Then we can hear it in the loudspeaker that the receiver is switched on, switched off in a certain rhythm. I don't know the frequency of this blinking PLL signal in case of unlock. I will check it. My idea is that one of the owners, the previous owners, was a white sticker, and he had no chance to see that the pilot lamp goes off. But with this method, there's an acoustic signal in the receiver that the PLL is unlocked, and in this case, this input transistor is muted, and this is an indication for this old man that the PLL has a problem. That's my assumption. Well, I will remove this. I will cut the wire here and add this 1.5 kilo ohm resistor, which goes to positive, but we have here 1.5K and we have here 100 ohms, so this pin here in general is low potential, 15 by 1. So when we have a 12 volt, we have a less than 1 volt source voltage. I will cut this wire or unsolder it and add this 1.5 kilo ohm resistor. The new resistor R, or the new old resistor R409 or R9 is in place. You can see it here. There are some other modifications on this board. I don't know whether they are original or not. For example, this wire, this shielded coax wire replaces, this shielded coax wire replaces the trace. The trace is cut here and is cut here and is replaced by the shielded wire. Similar I see with these capacitors here, they are connected directly to the shielded cables. So I assume this is a later modification, maybe for better image rejection or spare reduction. I don't know in the moment. I leave it as it is. I reinstall it and then we will see when we fire it up what happens, whether this board is okay or not. The next, and I think the last mod we have, is a connection from the SSB IF unit, soldered here, to the FM IF unit, soldered here. I don't know what this is, which signal has to be exchanged between FM and SSB. It is a tone call, the burst, tone burst, to feed it into SSB as an 8 for tuning the PA or so. I will take out both units and then we will see. We have a connection from pin 6 of FM IF, which is fed with a signal plus 8 volt at FM. With this one, can see it? Yes, can see it. This signal, and it is connected up to this pin 5 from the SSB unit. What it does, I think it only additionally blocks this diode, makes this diode non-conductive in case of FM. But I see the output is here. What is this? Pin 5 from SSB. Where does it go? I check it in the schematic. One moment. Now understood. In case of transmit, we have here 8 volt plus, which makes this diode conductive because the voltage from the DSP is only 3 volt DSP output, because we have, in case of SSB, in the DSP signal we have 8 volt, and this is divided by 3.3K and 1K, so we have here 2 or 3 volt. This diode is conductive, and this one also. In case of RX, it is not clear because this voltage goes down to 0, but here we also have 0. because we have no SSB. So in FM, this diode is obviously not clearly blocked. So someone added the voltage from the FM, 8 volt FM, to this pin. I will remove this wire, and when we fire it up, I will see whether we have a problem or not. Another modification I've forgotten to mention, we had here a coax cable which was cut. I followed this cable and it ends up in this connection in the ALC. Interesting. And here is a wire disconnected. So maybe someone used this ALC as an output. Here we have the PLL, where the local oscillator is generated. Maybe someone had a circuit here to feed out the frequency from the PLL for an external counter. It would have made sense. But this unit was not there. The amplifier and the direct connection of the coax cable is not advisable. We always need a buffer amplifier or so. I assume that this was the intention. I will resolder this pin which is cut off for the ALC. Okay, we do not need ALC in the future, but just for original layout, I will do it. This job is also done. The ALC is rewired. Luckily the wire was long enough. I could squeeze out some millimeters to have a good solder connection without any damage of the wire. Now all visible modifications are removed. I'm only waiting for the new pot for the RF gain setting. It will take some time, so I stop part 1 now. As we have seen, such old transceivers always have a history. Yes, we can say it's a history. Several owners have some ideas. Maybe some ideas are good, other ideas are not good. There are many proposals published in various journals and on the websites nowadays. Such modifications are always dangerous. We don't know what the intention is, so I try to remove them and to understand them. In general, I don't like such projects, and I refuse to accept works with such modified, slaughtered transceivers. In this case, there is an exception. It's a private reason for me to do this job. Anyhow, I don't know where this journey will end. Whether we have a good working 2-to-1 R at the end of this project, or I have to use a big hammer and stop the project. We will see. Stay healthy, stay tuned. See you on this channel.